Okay, so great. So you see my screen, and on the screen, you can see the table here gives all the list operations. So what we want to do, the client shouldn't know anything about nodes. Okay, the client is the client code, so the code that needs to use a linked list for whatever reason. Now, so far we haven't seen any clients that have this dire use for this data structure, single linked list data structure. Everything so far we've done could have been done easily using arrays, no big deal. But maybe these structures, maybe they're useful in certain circumstances more than the arrays are. So we'll see what those circumstances are later. For now, let's just implement this data structure the way we've described it before. So what we have now is the single linked list class and the client code that presumably wants to use it with artificial contrived examples today, but later more useful practical ones. That client code has absolutely no reason whatsoever to know anything about the node structure. Does it have to know nodes? No, it just needs to take data items like 1, 7, 2, 5, and put them in this linked list. So the client code knows nothing about the list, therefore, nothing about the node. What we'll do is, well, in this class, we're not big about software design, right? But we tend to talk about software design every now and then. So what we'll do is we'll make this node class not a separate class, but a nested private class inside the linked list class. Now, it's possible that you've never used nested private classes before, but it's no big deal. They're easy to use, and then I'll add a couple of exercises later for the next quiz where you get to use private nested classes, see what they're all about, and the syntactic issues surrounding the use of those nested classes, and so on and so forth. But they're super easy to use, and we'll see today how they are. Okay, so now, and what we'll do is we'll keep that node nested inside the single linked list class, and the class itself, the linked list class itself, will keep these references to the nodes, and as needed, we'll update them. For example, it should be able to link nodes if it needs to, or remove nodes from the list, and so on and so forth. The client code, on the other hand, interacts with this singly linked list class using this API. So this is an API. This is an application programming interface, meaning that the client code doesn't care whether the singly linked list has any knowledge of nodes, uses nodes internally, doesn't use nodes internally, couldn't care less about it. All it needs to do is create a list and then call methods on that list, like maybe add first, like add an element to the head of the list, to the start of the list. Add last, add it to the end of the list, and so on and so forth, removing elements, okay? So if you, like, I've updated this document here on Canvas. I've changed the names slightly, okay? So before we had add in front, now it's called add first, okay? This is, I guess, to be a little bit more consistent with the book, but could have called it anything. Doesn't matter, as long as it's clear what we're doing here, okay? So now our job is to implement this class. Toward that end, I'm going to go to any questions so far?
There's an inconsistency between the code you have uploaded for Lab 4 Part 1 and for that table right there. Your method is named insert first rather than add first.
Okay, I'll change it to add first in a second. So did you guys download this? So here's what I'm going to do. You guys see my screen? I'm creating a new folder for, I think today is something like, I guess I'm going to have to open this. September 23rd today. Okay. Inside the September 23rd, inside the September 21st, you're going to have to download, I'm going to download these starter files right now. So we need these for today. By the end of today, we just need 2 files. We just need SL list Java. So I'm going to download this into my September 23rd here. The node structure itself, notice how simple it is. And that's the way we want to keep it. There's nothing else we want in this node class. We want to make it private. Inside, notice this is called a nested class. So I'll show you better in an IDE. First, let's download this. But this is just one helper class of only a few lines, and that's the way we're going to keep it. We're going to keep things super simple. We just need those 4 methods implemented. First, okay, so let's download this. And then we have this second one that we need to download, which is just the test files. Please go to Files, You guys see my screen? Please go to Files. And we have Lecture Starter Code. And we're at SL Lists, which is singly linked lists. I'll update the link later. For now, please go to not End, but rather Start here. Go to Start. And both of these files are here. So please download test list Java. Okay. So there it is. And now what we need is to open up my IDE. So please open up your IDEs. And I'm going to go to my desktop, September 23rd, open that, and that should do it. Okay, so here we have our helper class, and I'll open up the nodes in a second. So this is it. This is the node. That's the picture of that tiny little node there. It's a recursive structure in the sense that it's able not only to hold an item, a data item called item on this line, but also to link to a node of the same type as itself. Okay, so that's what we talked about last time. Now, we also have, notice that we have a couple of private variables. So clients shouldn't be using any of the nodes or that n. It's not clear what n stands for, but as you're making this data structure, I'm saying that n is going to be the size of the list. The clients get to communicate with this class through the methods that are posted in the reading assignment, the 4 methods that include, for example, size method. Here's the size method. It's already implemented for you. It's just a one-liner. The size method simply returns n. And as we implement our add node methods or remove node methods, we'll be changing the value of n accordingly. When we add a node, we'll increment it by 1. When we remove a node, we'll decrement n by 1. But n will always be the number of elements currently in the list. What did I just do? Oh.
You copied and pasted the
Okay.
method inside itself.
Okay, so return n. Okay,
You
so
got
this is, what's that? Oh, I have an extra thing. Okay, thank you. But when we create this linked list class, we want to initialize these variables here. We'll do this in the constructor, first and last reference variables. Clearly, they're of type node. They refer to nodes. What is their purpose? So imagine all these little nodes linked up together. First, will always point to the first node. Last will always point to the last node, no matter how big the linked list is. You have a billion items. First will be at the head of the list. Last will be at the billionth item. You have 2 items. First and last will be next to each other. You have 1 item in the list, and we'll see that we'll have to deal with these special cases. Both first and last will point to that single node that's in the list, right? So again, first and last just simply point to the head and tail of the list. We could have called them head and tail. Frequently you see that such. But we're going to make our code as neat and short and nice as possible. We only need these 4 methods, and we're keeping it simple. None of that bloated stuff, and we'll talk about bloating code later. When we create the list, what we want to have is first to be initialized to null and last to be initialized to null, okay? And n to be 0. That's what we want to do. So that's it for the constructor. You make an empty list. There's nothing in the list right now. You have 0 elements. If you queried, if the client code queried right now, this one, and maybe we should open it, and it's always a good idea to have test cases right away. So some people write test cases first and then insert code there, and that's a good practice to follow. We're not quite doing that in this class, but actually let's do it. So what I'm going to do is I'm going to open my test case. Here's my test case. For now, I'm just going to comment these lines because I don't have anything implemented there. So what I'm going to do is once I'm done with this piece of code, once I've created an empty list, I'm simply going to query the size of this list. So I'm going to say list size, and I just want to print this, okay? So I just want to print this. So what I'm going to say is I'm going to say I'm going to copy this, okay? And just print the size of this list, okay? That's all I want to do. Okay, so let's run this. I'm going to run this. So you can run test list main, and here it is. It prints a 0. So what happened here is that I've created an empty list. If I wanted to print, for example, first or whatever, that wouldn't be possible. Okay, so by the way, you could, how can I print true here? So I want to check if the list is empty. What should I do? Is empty. Should print the Boolean is true, right? Let's see. Okay, so it prints true. So I'm testing along the way. So far, all I've done is I've just created a constructor, and that seems to work just fine. That's just fine. Okay. This seems to work. Okay, so let's continue. Now, before we move on, I'd like to, this is really not a data structures thing, but a Java thing. The first two lines initialize, that initialize first and last to null. Okay, by the way, people, so what is null? Null is a special keyword in Java. It simply tells me that this reference variable is pointing to nothing on the heap, right? It may have a type, first has a type. It is of type node here, but it points to nothing. Node hasn't been created, so it points to nothing. Now in Java, because the way Java evaluates expressions, and it does it from right to left, you can do it in a single line. So the two lines that I had 2 seconds ago, you can write it in a single line. So this goes from right to left. It says, well, here last is a reference variable that's going to get a null. And then that itself, that assignment in Java is the way it is. That evaluates to null. And then first gets that null too. So that's kind of a Java thing. Okay, you can do it in several other languages. Anyway, let me run this. When you run this, you should get the same. First of all, I'm not running it. So here I am. I'm running it again. And this time, so I get the same result. Okay. Okay, we're done with the constructor. We're going to keep it that way. That's our constructor. Okay. This is good. Time-wise, we're doing just fine. We're going to finish it today. We're going to have a very productive day. Size and is empty, those are implemented for you. And also at the bottom, there is a toString method, by the way. That's also implemented for you. You can print this. We'll print this in a second. For now, let's just get to this method, insert first. Okay, so this is one of the 4 methods that we're implementing today. So let me bring up my notes, my cheat sheet, so to speak, this one. Okay, and this cheat sheet of mine, and let me actually just see if I can get both of these on the same screen. Here's my cheat sheet on the right screen here. And what I'd like to do, this cheat sheet, to be scrollable and single page. This looks better. My implementation here, you're going to see, I don't know if you guys can see it. Here's my method. You guys see this screen? Okay. And here's my picture. Okay, that's the picture of our list. That's the way it's going to be, no matter how many items in it. First, by the way, first node, we'll change it to first, and last node to last. I think it's clear, just have short variable names with this, but you know, it's clear. I think this pictures are clear. Add front was our previous method. That is now add first. Again, I'll change the names. Add front is going to be add first. Okay, insert first we have. Okay, I'll change it to insert first. Okay, this table, but just make sure you're not confused. Like, that's my fault. Called it one place, I called it add first, then I'm calling insert first. So I'll change one of the names and update the nodes accordingly. Otherwise, the nodes are just fine. The pictures are just fine. So here's my picture of adding a node to the list. Okay, this is my insert first method. When I'm inserting the node, so here's my list, the top picture. This is what the list looks like. It only has, suppose it only has just 2 elements in it. I want to insert a new node. Now the client, what does the client care about? The client code doesn't know anything about nodes. Like, this is the client code. The client node code wants to say, here, list, go ahead and insert item into this list. This item's name is like 8. The client just wants to insert like 8 into the list. Like, when you use somebody's software like Excel, you don't care about the data structures behind the cells. You just want to put number 8 in the cell, and that's it. And that's exactly what the SL list is going to do. You're just inserting an 8 into the list. So the client just says this. My method will receive this item, an integer in this case, because I've created a singly linked list of integers. Okay, so this method, insert first, called here, receives just the data item. There are 2 situations that can happen. First, the list can be empty right now. So my first and last pointers from the previous picture there, these first and last pointers from the previous point, can be pointing to null. We want to deal with that situation as a special case. So if this list currently is empty, what I'd like to do is to assign my first and last references to this new node. So let's type this in. Again, I can do this in one line. So let me, should I do it in one line? Well, in 2 lines, this is the way I do it. First gets assigned to this, creating a new node. Notice again, the node itself is internal to this class. The client didn't know anything about this node, as well as last. Okay, so let me aim this to like last. Again, this is just a Java trick, just to have it in one line. Both first and last are assigned to this new node. Okay, that's in the case when the list is empty. There is one more thing I should do here. I must set the node's item field, that is the data field, to whatever value I receive here, to item. So let's just do this. Okay, so all I have to do is say that first item is going to be this item. Okay, that's it. But I also want to say that last item is the same thing. Last item. Do it in one line. I want to do it for both of them. Here comes the, inside the else comes the interesting part, which is like this picture, reassigning the pointers. How do I make the new list node that comes in here, this new list node, how do I make that the first node of the list? Well, I want to have my first reference variable, first node, point to the new node. So first node must point to this new node, and this new node that just came in, it has its own next reference, which is this dot here, and that must be re-aimed to whatever was the first node in the list to begin with. Does that make sense? So I think the picture makes it clear, right? Does that make sense for people? Okay, so let's write this. Okay, this can be, if you haven't done this, it can be tricky. And it's kind of important with the linked lists to do these things in a correct order. Otherwise, you lose references to the nodes, right? So it can be headachy to implement this. Okay, so that's why sometimes the questions about linked lists tend to be favorite questions of the interviewers, because the reassigning these pointers that you see on the screen can get tricky. Okay, but although in real life, like in the day-to-day on the job, you won't be doing this probably very infrequently, if ever. Okay, but you sort of have to know it. So in this class, we're concerned about how these things work internally rather than using the library methods. There are many data structures classes that simply show people how to use the library methods in given languages, like in Java, for example, which is a skill of its on its own, agreed, but still not quite a data structures class. So what we'll do is we'll keep a reference to the old first variable. We'll call it old first. So I'm going to create a reference variable. It's going to be a node, right? And okay, so it's going to be item. Okay, this new node, and I'm going to call it old first. Okay, this is what was the first before I came in with my new node. Okay, so I received my new. I've created my. Okay, I'll create a new node. So I've received an item here, but first I need a reference to whatever was the first node. So my old first is going to be whatever first was pointing to. Is it clear what I'm doing by this assignment? I'm assigning references right now. So first was a reference to some node. Line here. First was pointing to this old node. Now I'm creating a new node, and I'm keeping the reference to this old first node that I had before that first was pointing to. Why do I need to keep it in memory? Because now I'm reassigning first. I'm following this picture. Because now I need to reassign my first, okay, to this new node. To this, I'm now creating this new node right here, as I did before. Okay, so I want to do that. Now I want to create this new node right here. And the last piece is just to set the item value to whatever item I receive from the client, right? So first item is going to be this item that I receive, right? Does that make sense? And one more thing, I have to say that the first next is going to be what? My old first. That's why I needed my old first to begin with. That's it. That completes the implementation. So first of all, Now, maybe this doesn't work. I mean, we have to test it. But the logic that you see on the screen on the right-hand side is exactly the logic that you see in code here on the left-hand side. So let's test it. So here I have my insert item 8. Let's insert all these items. In fact, I'm going to uncomment all of these. And once I've uncommented them, I want to print the list. By the way, I have a toString method. I'll tell you about it. It prints the list. So you can just simply say print list, and it will print. So let's see. So let's run it. And here I have the list. Okay. Okay. We don't need these is empty. We should check that later too. So let me remove that. So if you run this, I have a list printed that way. That's my linked list. Okay. Now these arrows and all of that I inserted it in the toString method. You can remove those if you don't like. But for now, like the first attempts to print these things, I want to stress that there are arrows. These guys are linked. So that's what this arrow is all about. And then the last guy points to null. Okay. So it's just a way of printing the string. Later you can remove these arrows and just simply print the string differently, right? You can remove these arrows here and print the string if you'd like, just 2168. Okay, so any way you'd like, but there is no need right now to sort of like do that. Okay, so I don't know, we can comment this out. So print the list like that. Okay, that's fine. So we have our add first method implemented. Looks like we're able to add these elements. First of all, we should print the size too. Let's see what the size is now of the list. The size is 4. I have 4 elements, 1, 2, 1, 6, 8, okay? The fact that this 8 points to some other node, which is null in this case, that doesn't matter, it points to null. So the elements, the items that the client inserted, as far as the client is concerned, the client doesn't need to know it's a linked list. The client only cares about 2, 1, 6, and 8 being there in the order that they inserted. Any questions about insert first? Okay.
Yeah, I've just got one quick question. So in that line below the if is empty, that constructor that's called the new node item constructor, we didn't actually write a constructor for that class. So I'm just wondering.
Oh, yeah, the constructor. Okay, so in Java, if you go okay, did people hear the question for this class? This private class that I'm using. By the way, the enclosing class, which is so you get the terminology, right? So you have my private class is nested inside the enclosing class. The enclosing class is SL list, singly linked list. Inside, I have this node that I'm deliberately keeping as simple as possible. Just 2 fields in that. So now in Java, when you create a class, if you don't write a constructor, Java automatically gives what's called a default constructor, right? So you write a class, you didn't write a constructor. If it's a concrete class, client code should be able to instantiate that class, right? So you have to have a way of making objects from the blueprint, from that class. And Java gives away. There's no constructor. You didn't write a constructor. Java gives a default constructor, no argument constructor. As soon as you write your own constructor, like we did last time, we had the slightly more complex version of the node class, where we actually did write constructors. As long as you put a constructor inside your class, Java has amnesia all of a sudden about its own ability to put constructors in there for you. You put a constructor, if you put like an argument constructor, Java removes this no argument constructor that it had inserted before, that it was capable of inserting if you hadn't written your own. Now Java doesn't know about it. So you write one constructor, one argument constructor, for example, then your class will never have a no argument constructor once you've written your own. Does that make sense? That's kind of a Java thing. Does that make sense, right? So the point is that I have this private nested class here, and I'm able to instantiate the objects of that class from the enclosing class. And the enclosing class, the singly linked list class, is the only class that cares about the existence of nodes. Node is private to it. The client, this guy here, the test list that wants to use the list, doesn't know anything about the node. If I try to use the node there, see what happens. Won't even compile, won't be able to find the node there. Okay, now we have our insert first or add first. Now I have to really make this add last. I really want to refactor. It's 2 seconds, but yeah, at first. Okay, I've changed it. You don't have to change it if you don't know how to quickly refactor the code. Just don't worry, otherwise you'll get a bunch of errors. Just keep it that way. All you have to do is just, if you're using IntelliJ, it's quick actually. You right click on your method name that says add first, and you click refactor and then rename, and it will, inside the whole folder, notice that it automatically renamed this insert first to add first to begin with. All right, so now we need to keep moving. It looks like instead of breakout rooms, I'm going to have to do it myself with your help. Okay, now add last item. So here's my list, just up to here, just this node, 12, 7, and 11. That's what my list was before. Now comes a new list node that the client wants to insert at the end. Okay, now one of the homework questions that I'm already thinking about is to implement this method without having a reference to the last node. What would you have to do? You'd have to traverse the entire list to get to the last node just so that you could insert something at the very end of the list. The purpose of keeping this reference last to begin with was to be able to insert this last node relatively quickly. Okay, but can we do it? That's the question. Okay, so let's see. Where's my add last? So here we are. If it's empty, so add last. So here's my add last. So if it's empty, what should I do? If it's an empty list. Now you helped me out because like with the
same thing you did for when it was empty, for first.
Same thing as I did with that one. So even so, if I copy pasted this code, would people be too upset? That will save us some time, right?
Could you call add first inside add last?
Add first inside. Oh, okay. So and then what? Okay, so
Copying the code, just call the other method.
okay, let's try it. If you called it, what would happen when that method exited? That's a good point because you're thinking of saving yourself some typing, right? That's the right way to approach it. But there's really no good way. Yet this is the right way to approach it. Every time you copy paste some code, you should be thinking, is there a way of abstracting this away into a separate procedure? And there is, but it's only a couple of lines. So but calling add first will not work in this case, the way add first is written. Because you call add first, there is nothing inside, this will run, but at the end of the day, my n gets incremented. And I kind of don't want to do that. But it's a good idea and you should try it, maybe, you know. But for now, let's keep it that way, right? So I'm just adding, just make sure I didn't make any mistake. Shouldn't be. Yeah, so doing exactly the same thing as you've suggested. However, if I have more than one element in the list, okay, notice again, if my list was empty, I'm dealing with these special cases. If I have more than one element in the list, then what happens? Now, so I'm looking at this picture. I want my last node, here's the last node. I want my last to refer to this new node that just came in. So I must, first of all, I must create a new node to begin with, right? So I want to assign last to this new node. So I'm going to have a new, so help me out. I'm lost. Am I doing the right thing? Am I doing the right thing? I don't want to be just typing things and then, you know, people are like, what is he doing?
So kind of similar to the add first method we just implemented, you have to create an old last reference and point it at last.
Yeah, that works, right? The only thing I want to have the next reference of the last node, this arrow here, point to this new node that I've just inserted, right? Remember this last node at the top part of this picture was pointing to 11, not 11, the node that has 11, which was the last node. Now I want 11's next to point to the new node. So I'm missing really one line here. Okay, so make sure, so last next has to be pointed to the new node that I've just inserted. So notice I have two lines here pointing to this. Okay, last and last next. Does that make sense? So it is exactly what the picture says. Okay, oops. Okay, so first let's test it. Should be removing these items, okay? I implemented it in this order, that's fine. Add last. So let me write a new add last here. So here's what my list looks like. So if I do list add last, and let's add 777, like an integer that you can recognize was added there. And then I want to print out my list, and let's see what happens. So what happened here? Why did I get an error? That's probably what did I forget? Obviously forget.
Item.
Yeah, item. So last item is going to be this item, right? Okay, this is homework assignment, I think. But now we've already done it, but that could have made a good homework assignment because I was clearly missing it. Could have, you know, if I didn't test it. But for now, let's implement the rest of them. So the last item, okay, this should work. So let's add one more just to be sure. Make sure it works. Okay. All right, so that's our add last, okay? That will, what's time-wise? We have 2 more methods to implement. Perfect, timing. Okay, so let's continue, that works. Add last method just worked. Now, how about removing first and removing last? I had these, for now I'm just gonna comment these out. That was like a test case that worked. For now, let me just comment these out. But that worked because next time I want to test, like removing an item. Now, how about removing an item? So I want to be able to remove the first item and remove the last item. Heads up, the homework assignment will be removing from the middle of the list. Favorite interview question. How do you remove from the middle of the list? You need to be iterating through the list somehow. We'll talk about iterators next time to simplify that stuff. For now, we'll do it the standard way. Next time, we'll make this list iterable itself. We'll make life for the client code much easier. Okay, for now, we'll do this inside the class, all this iteration inside the class. The client code can't really iterate through the list as it stands now, unless the list implements iterable. We'll talk about that next time. I'm removing the first item. First of all, I have to decide what's going to happen. If there's nothing in the list to begin with, and I'm removing the item, then the client code calls remove first item. Well, if there's nothing in it, there are a bunch of ways you can deal with it, but the simplest cop-out would be to just throw an exception, and that's what we'll do today. We'll throw a new runtime exception so that we don't have to tell. Ideally, you'd make your own exception object, like or there's no such element exception, but you have to like add like extra code just to use it. So for us, if there's nothing in the list, we'll just throw an exception, and the code will say, okay, so there's nothing in this list, goodbye, and that's it. When I go back to my API, this table here that tells me how to implement these things, it says that when I remove the item, I want to return that item to the caller. That is, the client removes the item and gets that item back, so that I can say things like you see here. Things like you see here. So I want to say, like, remove an item, like this removed item. I want to have a reference to this removed item. And then I just want to print that item. Maybe I want to remove something from the list and use that item in my client code somewhere. So that's what we're doing. So remove first. Let me go back to my cheat sheet, which is my picture. The top line again, part A, is the way the list looked to begin with. Now my first node is going to point to the second node, whatever was the second node. The item that was first will be assigned to a new reference variable called removed item, and that guy will be returned to the caller. Does that make sense? Okay, so let's do that. So here's the picture. Now you help me. Now this time you help me out. So we already have a couple of lines. We've decided that if the list is empty, we throw an exception, we exit. So the list is not empty. There is at least one item in the list. And if I have at least one item in the list, I know by maintaining this invariant that first always points to the first item on the list. So first item is going to be an item that I'll eventually return. But notice one thing. I also have to process separately the situation when I have just exactly one item in the list. So what we'll do is we'll check if So we have three separate cases. There's nothing in the list, in which case we throw an exception. There is exactly one item in the list, and there is two or more items in the list. Okay, these three cases have to be done separately. Now, if there is one item in the list, what do we do? Help me out. Like, I'm lost.
Would you make first and last back to null?
Yes, exactly, right? So did people see this? Didn't that make sense? So first is null. I can say first is null and last is null in 2 lines, or I can just do it in 1 line. Okay, these both have to be null. Okay, and then what do I have to do?
Before that,
Return removed item.
Sorry, one more time. Okay, I didn't hear. Maybe somebody else heard this and maybe help me out.
He said remove. He said return the removed item.
Oh yeah, return. Oh, okay, so we're returning this, the removed item. Yes, for sure. Yeah, we're doing this. But for the case where I have more than one element in the list currently, I need to do something. I need to update as the picture tells me, I need to update the reference, this first reference here. Okay.
So would you change first is now equal to first dot next?
Yes, exactly. So first is going to be first dot next, right? That's exactly right. And then is there something I'm forgetting though? I think.
Then you set you assign remove item to the original first.
Sorry, one more time.
You assign remove item to the original first, so you return.
Actually, I already did this at the beginning. That's correct. That's correct. But I already did the very start, so I can save a line here. Yeah. So, but you're correct, right? So I really have one line here. Really have one line here, right? That's the way my code looks, right? Here's my if-else statement here. Then I, of course, don't want to forget decrementing this thing, and as you've mentioned, remove this item. Okay, so finally we come to the most interesting part. Okay, first of all, we should test it. Of course, I don't know. You never know. I'm going to run this. Remove first. So I'm storing it in an integer item. So this is my list, what my list looks like of 4 elements. And now I'm removing 2 is the first item. So I'm able to remove 2. And now printing the list again, it looks like this. So I'm left with this tail with 2 removed. Of course, I need more test cases, but for now, let's just move on. This works. Finally, the most interesting piece is remove back. You guys see this? This is slightly more complicated. And well, not by much, but some of the code is the same, except like this reassignment of pointers here. By pointers, I mean references in Java. So help me out. So here's what we're doing. Remove last. First of all, if there's nothing in the list, I'm throwing an exception. That's done for me here in this line. As before, I'm saving up the last item, right? If there is at least something.
Okay, thank you.
No problem.
Okay, so if there is at least something in the list, then I'm saving up in the item, right? So I'm getting this item. And now, again, I have 2 cases. If I have exactly one element in the list, exactly one item in the list currently, then what do? I something similar to what I did before, right? This is when I was removing the item from that list, remove first. And if I remove last, is there anything else I have to do here other than what we did before? Isn't that logically the same? Remove last and remove first is just the same thing in both. So not much work to do here. Once I've thought about removing the first, it's exactly the same. So I'm copying the code. Here I have to do some work. And last time we had this discussion about, notice that I need a reference to this. So my 5, the node here that says in the picture that says 5, that was the last node. I want to get rid of it. So the new node that just came in, to that new node, I want a reference next pointing to it from the node that was previous to 5. So in this case, 11. Okay, so you have a last node reference that's pointing to the last node. Okay, so here's the last node. I want it to point to the one that came just before, not the one that has 5, but the one that has 11, right? So how do I assign it to that 11? So help me out now. Like we have 8 minutes. 8 minutes.
You have to iterate through the whole list because we don't have a before variable.
Yeah, and there are 2. The last time we did with a for loop. And I actually made a mistake. If one of you didn't catch that mistake, would be stuck debugging it for a while. So one of you caught it right on time. This time, I'm going to do it with a while loop, just for variety. And at the end, you choose whichever you like, for loop or while loop. This time, we're going with the while loop. So what I'm going to do is, first of all, I'm going to create a node, which will be in this picture. It's called current. We called it X last time for some reason. Should have called it current, but whatever. So I'm going to create a node item, right? So this guy is, well, item. And that guy's name is going to be current. Current. Okay, so current is the guy's name. And initially it's going to point, notice there's a typical while loop idiom. So it starts out by being the first node, and then it's going to iterate until it reaches the next to last node. How do I tell that the guy has reached the next to last node? So current next, you know, what is it ever null while I'm inside the loop? If current here is pointing to any of the nodes that are inside the list, the next reference of the node to which current is pointing is not going to be null, right? So while current next is not null, right? It is not pointing to last, because I need the one that came before is not pointing to my last node, right? Well, it's not pointing to. I'm advancing my current. I'm setting my current to current next. So this is what we had in the while loop before. Okay, so I'm advancing my current. And finally, here, when I'm outside of the while loop, what my last is going to be current. Okay. Okay. And then what else am I missing? Let's wrap this up. Current next is going to be null. Okay. And of course, I need to decrement this. So if you missed something, this is equivalent to the for loop that we discussed already last time. I'm essentially iterating through the entire list, beginning from the first to get to the next to last node. That's what I'm doing, okay? Okay, so, and then of course, at the end of the day, I'm decrementing this. Now, we're done with this entire implementation just in time. We have 5 minutes left. So I'm going to, now I'm commenting. And I'm gonna run this, and you'll see what we're getting. Okay, so we're getting exactly the right thing, because the last line, we tried to test this running the exception. So that it's doing the correct thing, but if you comment that line, you should get the following output. Created the list to begin with, tested its size, removed the front, and you should add like a bunch of your own cases. So I'm left with this, then this. Then I've tested remove last, which was 8. So now 8 is removed. I'm left with this 1/6 piece of the list. Okay, now the size I've tested again, size to make sure the size is updating correctly. Then I removed 2 more items. So you see, so I've removed last. I could have done remove first here, same thing. So let's do it remove first, just to, if you remove first and this remove first should, or even if you leave it remove last, should still give this exact same output if these methods work correctly. So when I was left with a list of size 2, I removed 2 items, whether both were removed first or both removed last, or one removed first, the other removed last. And I'm down to like the 0 items when I removed those 2 items, down to 0. And that's it. At this point, I have 0 items in the list. And if I try to remove something from this list, the way we coded this today is to throw an exception. So if I try to remove from an empty list, right, I get this exception. Where does this empty list come from? It comes from whatever we coded here today. We said, say that it's an empty list. It could have been done nicely, but that's where that comes from, okay? Right, does that make sense? So you have until 6, right, to upload this. Ideally, you can upload it right now, but if you were listening to music, then you may need another 15 minutes or so. Any questions? So what, yeah.
I'm pretty sure my code matches yours exactly, but I'm not getting the runtime error to throw, or the runtime exception.
Yeah, because make sure you remove remove exactly, just make sure your size of the list is 0, and then you remove either first or last. It should do it. If you have, if every time your list is
777 and then 9999 in your list.
sorry, one more time.
I commented those lines out, but I'm not sure what's going wrong because I'm getting. I'm not sure. I'll take a look at it. I got to
Yeah.
take a peek.
So yeah. Okay. So then make sure. So should I can extend it by the end of the day if you'd like, because this is like. Do you want to have like until 11? I don't mind as long as you have it today, right? Today. So now is the time to have this ready. You have a singly linked list. This is the one that you, so next time we'll talk about stacks and queues. You'll use this to implement your stacks and queues. You will not be using Java's stacks and queues in this class, in the homework assignment, homework assignments. You will be using your own versions of stacks and queues. We'll talk about them last time. Once you know about linked lists, implementing stacks and queues is like no work at all. You just simply know what stack and queue are, as we'll see, but that's next time. There's one more thing we need to do, though. We need to make this code a little bit nicer in the sense that we'd like to give the client the ability to iterate throughout data structures. We want to make this data structure, the singly linked list, iterable, just as an array list is in Java. And in Java, linked list, you don't want to have your own class. This is yours now. You don't want to have your own singly linked class be any worse than Java's class. In fact, it will be better because it will be lean and have exactly the methods that you need it to have and nothing else. And we'll talk about those shortcomings of Java's classes that come in the libraries, which are excellent classes that have been tested a gazillion times. They work, they're optimum, work just fine. But there's one flaw that cannot be avoided by design. And that is what experts call fat implementation. That is, they have more methods than they actually should have. On the one hand, it sounds like, well, there's stuff there I can always use. On the other hand, it turns out that it's actually a bit of a curse to have more than you need. Okay, but anyway, we don't want to talk too much about software engineering here. We just want to get the structure straight. The design issues are kind of, yeah, we'll talk about them every now and then. But any questions about the structure itself? Okay, you will expand this one to add this ability to retrieve things from here, from this list, by index. Remember that we began talking about lists and array lists, which were our first concrete examples of lists. Recall list in Java is an interface. As entities or collections that care about indices. That's what list is. It cares about its index, about its order. In this version, we don't have a notion of an index at all. That you get to do in your homework assignment, and I'll give you instructions, okay? And you'll have a nice structure that will be your implementation of a singly linked list from this class. You'll use that in this class, okay? All right, any questions? We have to end at some point. So we're like a couple of minutes overdue. Any questions real quick before we end? All right, so please prepare for the quiz next time, 20-minute quiz. So please be prepared for it. You know what to study. You have the drill questions. There's also optional crossword puzzle, just to make sure that your answers are correct. Make sure it fits in the crossword. That's just optional. You don't have to look at it if you don't like it. But the drill questions, work through them, you'll be fine. Make sure you know how the code works, right? Run that code that's there to ace the exam. If you do that, those drills, and you know why the code does what it does, you'll ace the test. I want everybody to get 20 points in this. There's no reason not to ace this test, like absolutely none. So all you have to do is study. And then I'll post the next lab tomorrow. Okay, so if there are no questions, I'll see you guys on Monday at the quiz.